There it is.
Okay, I'll give you a minute to download and then start.
Yeah. Okay. VS Code is up. Okie dokie.
Okay, so just a quick recap of what we have done so far and where we are and what we want to do next. Yeah, so we started looking at Numpy arrays. We look at how to create Numpy arrays, array dimensions. We talk about how we can index, how we index arrays and how we slice arrays. And we look at NumPy data types, thinking that we have more data types. I mean, some data types in NumPy that are not available in the standard Python data types.
Mhm.
Then we look at how we can iterate over NumPy arrays. We could just continue to write for high in these, for high in these, and hard. That get complicated, but then NumPy provide a function to iterate over arrays, right? Which is n iterate or something like that. So we'll continue and look at how we can split arrays, right? So this was the function I was talking about, and the iter. Okay. So how do we split NumPy arrays? So that's what we want to um look at for this class. How do we join and split NumPy arrays?
Okay.
Okay.
Nice.
Yep. Let me search this in.
Which is
Okay.
essentially now we're starting like at day one of the class.
Yeah. So I mean, the ones we have done so far too are so important. In fact, I felt like you already have everything we need to move on to the data analysis concept with NumPy array, but I felt also that I should just take time to, you know, go through everything, and you will see how all these um, stuffs that we have been looking, it might look like we are going very slowly, but you
Mhm.
start seeing by the time we start doing machine learning and all that, you see why it's important to take time to understand the data structures and improve on programming skills before machine learning and all that. Machine learning is very easy to learn, but implementing and writing the codes up is what is a bit challenging. So that's why I'm taking time. Like, okay, let's go slowly. Let's move very progressively till we get to machine learning, which will make sense. All right.
Mhm.
Okay.
Mhm.
Let's see how do we join arrays. Let me create one array np dot array. I want to create a one-dimensional array. 1, 2, 3, right? Array 2 equals, I didn't import. I have to import np dot array for, let's say, 4, 5, 6. I know I didn't import one all. Okay, so I created two one-dimensional array, call it array 1, array 2. If I
Mhm.
want to join this array, NumPy provides a function concatenate for joining arrays. So I can say I want to join this array to be np.concatenate. So this is a function concatenate. We can just supply the object, the arrays we want to concatenate, array 1, array 2, and then we can show our array. What do you mean?
Scalar index, scalar array can be to a scalar index. Um,
Oh, I think I have to put this thing in. I have to put the parameters that I want to concatenate into tuples. I have to put them into like bracket, I think. Okay, that works now. So what the concatenate does is that it joins the arrays, right? It just add them together, array 1, array 2, concatenate, add together.
Mhm.
So we can also join a two-dimensional. We can also join two-dimensional arrays, concatenate them. Let me create array 1 here. In this case, I'm going to use np dot arrange. I'm going to create a 12 array of 12 values, 12 element, and I'm going to reshape to 4,3. Okay, what is our array 1? So this is two dimension, 4 rows and 3 columns, right? I'll
NP
create
arrange
array,
12.
yeah.
1, 2, 0, 1, 2. Okay, so just to go back for a moment, the
Mm-hmm.
concatenate, how we need to put it in a tuple. Why did we need to put it in a tuple?
Yeah, so the thing is that you know, we have, let me show you this to explain. Yeah, I like that question. It's really concatenates. Okay, so if you look at the documentation, right, npy.concatenate, the you know, the module concatenate, it takes a tuple of objects, which are the arrays that we want to concatenate.
Mhm.
So based on the way they code up the module, the first parameter is a tuple of arrays that we want to concatenate. Do you get it? So
Yeah, and then
it's
the second, if we changed any of those other parameters, then we have to put it in like they're there, but they're hidden, if you will.
yeah, so like this is what I was talking about when we were discussing functions, right? So here they're saying that the other parameters are there, but they have default values. So if you don't provide the value for them, we are going to use the default values. And we are going to see the implication of using default values and then using the main or changing the values, right? We are going to see it. So if we don't provide the axis, for instance, it's going to use the zero axis dimension for the concatenation. Does that make sense?
Yes.
Okay. So we're going to see especially the axis parameter, what it does, basically.
Mhm.
Um, so here, so what I've done is to reshape that. Yeah, I want to, let's say I want to do another np dot arrange, right? I want to do, let's say 20.
Mhm.
This is to 20. Then I want this to be let's say this is also 12 instead. Or what I will do here is that I'll do np.ones. np.ones. This is going to create like an array of 1 values, right?
Mhm.
So let's say I don't know if the way it takes the dimension, let's say 4 by 3. Okay, let me check array 2. Okay, makes sense. So I have array 1, right, which is print, let me print array 1 and then print array 2. So this is array 1, this is array 2, right? They are both 4 by 3 dimensions. So if I concatenate this, array 1, array 2, right?
Double brackets,
Oh, double
everything.
bracket, I forgot. Oops. So the error we got here was that when I didn't put the tuple there, it is taking this array 2 as the index parameter, and the
Right.
index parameter takes integer, right? So it is saying
Mm-hmm.
that only integer scalar arrays can be converted to a scalar index. That's
Mm-hmm.
why I get
Mm-hmm.
this error.
That makes
So
sense.
now, look at what happened. It concatenates the arrays for us into one, combining, stacking the second below the first. Does that make sense?
Sure. Yep. The second below the first,
Yeah,
and yeah, okay.
just like
Okay.
adding it along the rows dimension, right?
Uh-huh.
The rows
Uh-huh.
axis. Now, this is where the usefulness of the second parameter of NP concatenate the axis. So when we look at this, it says by default, where is that? It says the default value for the axis parameter is 0, and then 0 dimension is the row, right? 0 is along the row dimension. If I what can I do? How can I concatenate along the columns? Instead of maybe what I want to do is to add the second along the columns, not, stacking below it. If I want to stack
Not
beside it,
second.
how do I do? So to do that, what I need to do is just change this default values. That okay, the default is 0, but I don't want it to be 0, I want it to be 1.
Mm-hmm.
Oops, sorry. Uh, um, I want this to be 1. You see what happened now? When I change the axis to 1, it concatenates along the columns. So,
Along, yeah. Okay, gotcha.
so the axis dimension is useful to like change the weight or the dimension. Sorry, the axis parameter is important to like change the dimension that we are concatenating along, right? So the first one, axis 0, concatenate along the rows. The second axis one along the columns, right?
Yes. Mm-hmm.
So this is the usefulness of, the default, changing the default values. Does that make sense?
Mm-hmm. It does. It does.
Okay. So we can also join arrays on new axis using stack. So let's see how that works. I'm going to use, what's it called? The arrays that I've created earlier. Then array 1, array 2. So what stack does is that it add the arrays and concatenate them or join them in another dimension. So what it will do is basically that it's going to increase the dimension of the new array. I mean, the new array we have +1 dimension. So if you look
Mm-hmm.
at this now, array 1 is a 2-dimensional array, array 2 is a 2-dimensional array. What this does basically is that it's like take array 1 as it is and then join it to array 2 on another dimension. Now we have a 3-dimensional array. I mean, like you can think about this like a kind of a cube, right? We have a cube. Give me a minute. Let me show it.
Sure.
So like I take this cube, right? Like imagine we have this array. This is a 3 by 3 dimensional array, right? 1, 2, 3, 1, 2, 3. Let's see. This is a 3. Let's forget about the other depth now. This is a 3 by 3 dimensional array. And let's say I have another cube here. If I use np.concatenate, right? Axis equals to 1. What that one will do is going to add another cube to the side. So I'm going to have, instead of 3 columns, I'm going to have 6 columns and 3 rows, right?
Right.
If I use axis equals to 0, I'm going to have 3 columns and 6 rows. Now that will add it to the bottom, right?
Right.
But if I use stack, what stack will do is that it will not add to the rows or column. It's going to add to a new dimension. So that means it will just stack this stuff to the back. So in that case now, I'm not going to have a 3-dimensional arrays. So this is dimension, the 3rd dimension now.
Yes.
Right? If I stack another one, it will add another stuff to it. Does that make sense?
Yeah. So essentially you're putting it in the back. And so the way that you reference that then is going to have to be new too.
Yeah.
Because you've got X, Z or X, Y, and now you're Z. Is that
Exactly.
right?
That makes
Okay.
sense. That makes sense.
Okay.
Yeah. So this is the let me see. Yeah, usefulness of stack. I think this 3-dimensional array. Oh, okay. I think I should use this this example 1D array. It's easier to understand 1D array stacking. So here if you can see for this 1D array, we have 1, 2, 3, 1 dimension. We have 4, 5, 6, 1 dimension. So when I stack that, it gives me 1, 2, 3 in one as one element and 4, 5, 6 as another element of a 2-dimensional array. So it stack it to a 2nd dimension. So we can also stack we can also use H stack and V stack to stack along the rows or along the columns respectively. So I want to
Oh,
stack
interesting.
along the rows. I'll just say H
So
stack.
what does H stand for?
Yeah, I think it's horizontal.
What's that?
Horizontal stack.
Oh, horizontal. Thank you.
Yeah.
Horizontal. Okay, that makes sense. Horizontal stack. And V stack is vertical stack.
Yeah,
Okay.
exactly.
So horizontal stack is going to stack it to the right. So we're still
Yeah,
going to have
exactly.
three rows, but 6 columns.
So what horizontal stack does is we have exactly, we're going to have 6 columns, right? But 1
In this
rows.
case. Right. 1 row, 6
Yeah.
columns. Okay. Yep.
Then if we do vertical stack, it's going to just do V stack. Okay, does that make sense?
Yeah.
Yeah.
Vertical
Okay.
stack. Yep.
So we can split arrays as well. We can split our arrays. I'm going to run this 2-dimensional again because I need that one. We can split our arrays, right? Like we have 4 columns, you can split into 2 columns or something like that. Let's see how we can split this. Let's see, I have array 1D equals np dot array 1, 2, 3, 4, 5, 6. Okay, we can now see np dot array split 1D. Oh, sorry, we have to provide the number of, okay, once 1D missing one required positional argument indices or sections. So yeah, we want to provide, like, we want you to split this into maybe 3. Okay, so it split that into 3 arrays for us, right? So we have one array that goes from 1 to 6. So when we split into 3, it gives us 3 arrays, and it split that one array into 3. Does that make sense?
Yes, it does. Okay.
Okay.
Yeah. Yeah.
All right. So now we can search for a value in a NumPy array. For instance, think let me create this array. Array equals np dot array 1, 2, 3, 4, 5, 6. Oh, I don't need to do that again. I have it already. Array 1D, I think. Okay. We have this array 1D. If I want to search for a particular array, or sorry, a particular value in this array, I can NumPy provide the where functions. So using I think, how do I do that? np dot where this array 1D is equals to, I have the value that range from 1 to 6. If I want to find where the value is equals to 3, what this does is that, oh, sorry, I have splitted array 1D. Okay, so I'll need to, I don't want to split it. I want to use the array 1D. Okay. Where array 1D equals to, what is this doing? I'm trying to get it. What is this np dot where is doing? What is it doing? So
There's there's a comma there, which is interesting in the array, but then I guess all I can it's in the third position, which is why it's referencing 2. I just don't, but in the array itself, I don't understand why there isn't, why it's, there's square brackets, and then there's regular parentheses, and then there's a comma. And
okay,
so, I mean, is that the same thing that would
so what this thing does is that yeah, like you see, it returns the index of the array. This will make you understand what it's doing. Let's say I change this to 3, change this to 3 also. Then when I run this, so you see what it does is that it is returning the index of the 3, right? So yeah, I found 3 in these positions. So these are the indices. So you know that it is there. Does that make sense?
It does.
Okay. Well, you can sort arrays. To sort an array, we would just have to like np sort, np dot sort array 1D. Okay, and then so here we have the array going from 2, 3, 2, 3, 4, 3 something, but here it has sorted it for us. So, any question?
No, I'm doing okay.
Okay. So the next thing we can do, we want to look at is how do we, filter array based on conditions. how do we select just some arrays that satisfy some conditions that we are interested in. To demonstrate this, um I'm going to use array 1D. Right, I have array 1D. Let me check. Oh yeah, this is my array 1D. Okay, now I want to use Boolean. Remember, condition, it result into Boolean values. Where this condition is satisfied is true. If the condition is not satisfied, it is false, right? So I want to create a filter or something. Let me call that X to be true, right? I just want to like random false. 1, 2, 3, 4, 6. 1, 2, 3. Yeah,
No
these are
commas.
6. Yeah, yeah. Sorry, there should be commas.
Okay.
Thanks for pointing that out. There should be
Sure.
commas.
Just wasn't sure.
Okay. All right. So I can filter this array 1D with the X arrays, right? The X is now a list of booleans, right? So what it does, if I use array 1D, and I use the indexing symbol, the square bracket, and I put X, so it's going to like just select only the what's it called, the position where the value is true. Now we have 4 elements in array 1D, and remember array 1D has 6 elements before, but because we have 2 false values in the list, it changes it to it doesn't select those with false.
Oh, interesting.
Where was the application of this? The application of this is that we can use this understanding of array select based on true, false, something to filter our array conditionally. For instance, let's say I want to.
It's a shortcut for just getting rid of columns or
Sorry,
rows. Is that right?
you say what?
Is it a shortcut for getting rid of rows or columns?
I didn't get that. Can you
Or
expatiate?
or or maybe there's a more specific thing that
Okay,
it would work for.
let me show this example, then
Sure,
you can
sure.
actually. So let's say I want to select values where values greater than 3 from array 1D. So I have this array 1D, right? Let me even put it here so that we can see what it array 1D. Right, 3, 2, 3, 4, 3, 6. Now I want to select values greater than 3, right? Condition. So what I can do is I'll just say, if I say array 1D, it's going to return it. But if I want to select values greater than 3, I'll just say where array 1D is greater than 3. And you see, I got 4,6. Got 4,6. So it used the condition here, right, to select the element. Does that make sense?
It does.
It used, so if I run the condition alone, I'll see that for the first one, is it greater than 6? False. This greater than 6? No, false. This one, the third one, which is 3, greater than 3? No, false. Then the fourth one is 4, so this is true. Then the last one is also true. So I just put this inside the indexing or selection symbol, square bracket, and it does the selection. And this is a very useful um, syntax. You find this thing very handy when we are doing, we want to select arrays, or especially in pandas also, right? We use, rows where this is greater than or something based on condition. It's something that we do a lot in pandas, and we are going to look at pandas later. Does that make sense?
Mm-hmm. Mm-hmm.
Okay,
Mm-hmm.
finally for today's class, we want to look at um, arithmetic operations. So we can perform arithmetic operations on NumPy arrays. We can add, like, let's say I have this. I'll just copy this my array one, and this I have already. Where is that? Okay, this one's. So I'll put it here. Okay, so I have this two-dimensional arrays of 4x3 shape. I can add a scalar to this. If I say array 1 plus 10, just calling the array and adding 10 is going to add 10 to all the values. And you can see now that our array 1 is now, let me print the original array, right? And then print.
Array 2 plus
No, I
10.
didn't want to
Okay.
add. I just want to print the original here. So we see this is the original array, right? Array
Yeah.
1 is 0, 1, 2, 0 to 8, right? Array 2 is all 1. So
Mm-hmm.
array 1 plus 10, just do like 10 to all the elements in the array. Does that make sense? So this is
Mm-hmm.
adding scalar to it, right?
Mm-hmm.
We can also add the array to one another. Instead of adding scalars, you can see we want to add array 1 plus array 2, right? So what we get here is, this is doing element-wise addition. 0
Oh,
plus 1,
sure.
1, 1 plus 1, 2, 2 plus 1, 3. So it's just adding, right?
Mm-hmm.
And it's the same if we just do it like this. We get the same because 1 is, instead of
Mm-hmm.
doing just scalar, we can just create one matrix and then
Mm-hmm.
add it and all that. Does that make sense? Oh,
It
so
does.
this is the
It does.
element-wide operation that I was talking about. This should be it. Okay. We can also like do element-wise products, right? So like I want to multiply the first element of this array with the first element of the second array. So to do that, we just do just like addition. Array 1 asterisk array 2, right? So we have the product there. Another product that we can do is scalar multiplication, right?
Mm-hmm.
I mean, not scalar multiplication, dot product. So dot product is like the matrix product that we used to do, and you like multiply the rows by the columns and add it and all that. So that is also possible. To do that, we're going to use dot, np dot for the arrays, right? Yeah, so this is what I have for today's class for
Okay.
NumPy. I think.
Uh, Question. So
Mhm,
on array 1, array 2. Okay, array 2 is just 0. Okay, so 1 times 1, 1 times 2. I get it. Okay, great. That
mhm.
makes sense. Okay.
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 Okay. So I think what we can do maybe for Friday is to
Mhm.
round up with NumPy arrays so that by next week we're going to start with pandas, and then
Sweet.
maybe we're going
Sweet.
to take a week to look at pandas, or maybe 2 weeks. Then after this, I think one thing that I would like to um, touch base at before we move to statistics is matplotlib, or not
Oh.
matplotlib, basically just like visualization with Python we talk
Mm-hmm.
about. the different graphs and how we can do that with Matplotlib and Seaborn. So yeah, this is the way. This is what I feel like how we should go
Great.
about it. Does that make sense?
Okay. Yeah, it does. Yeah, that's
Okay.
great.
Yeah. So we're going to call it a day. Yeah, and we're going to meet on Friday.
Okay. I've got a dinner date on Friday, so
Mm-hmm.
maybe Saturday could
Yeah.
work. Does that work for you?
Yeah. Saturday should. Yeah. Saturday should work.
Okay.
Yeah.
If I'm still sick, I'll be home and we could do Friday if it works for you, but if I'm not sick, then I was gonna go.
Oh, okay.